move that guy around, and for some reason it's pausing on us. But when I move it a little further and keep it going, what the hell? Anyway, you can kind of see, don't know what's going on here, why it's pausing, but when I move the slider to a new location and I hit play again, it's at the different place in the song. Oh, come on.
Problem with the simulator, clearly.
Of course. Yeah, it's a problem with the simulator. That's strange. All right. Well, you can, if you can trust me, this is how you implement scrubbing. You should be able to, and yeah, you can get the duration off the player. Yeah. All right. Failed demo number 1. How many more we got? So let's keep going. Let's talk some more about audio. There are a couple other, yes? Yeah.
Question about the scrubbing. How would you set it up so that it actually also indicates where you currently are in the song?
Good question. So the question is, if you have a scrubber that goes from, let's say, 0 to 1, how do you have that scrubber move along with your song? Does anybody want to take a guess on that? There are a few ways to go. Anybody want to take a guess on that? Yeah.
I mean, can you update the slider value as the progress is to the duration of the song?
Yeah. So your suggestion was, can you update the slider value with the progress? I don't think AV Audio Player gives you that as a callback, but some of the other APIs do. Like the audio cue that we're going to look at, it actually does. So you would get a callback that said, I'm now at time 15 seconds, and then you can convert that to a spot on the slider. Another way to do it, which is actually in the remote app, the way we do it there, because we're network driven, we want to keep network traffic down. We actually just when we know what time we're supposed to be at, we start a timer, and then every half a second or full second, we'll go in advance. We'll tell the slider to move to a different value. So, and then when in the remote's case, when iTunes says that it has moved to a different time, we go and we reset the timer, and we set the new value, and we start the timer back up again. So, yeah, the AV Audio Player, again, so it wouldn't give you that callback. Audio Cue would. And this is where we start getting into some more sophisticated APIs. So the Audio Toolbox framework gives you several different classes. The one we're going to look at today is the Audio Cue. But this will let you do something that a lot of people are really interested in, which is network audio. So what Audio Cue does is it's a way for you to feed buffers of data to the audio playback engine. And you can, so if you're generating audio, you can generate your sine wave or whatever audio you're generating in consecutive buffers. You feed that to the cue, and then the cue will play that for you seamlessly when you tell it to play. If you can get a few callbacks. I think I have a slide on the callbacks. No, I don't. So you can get some callbacks to know when a cue when a buffer has been completed. It will give you a chance to reuse that buffer. So instead of having to allocate all these buffers over and over and over, if you have, say, a fixed size buffer that you're working with, you can allocate it once, tell it to play, and when it's done, it'll tell you when it's done, and you can use it for whatever you else need. You need it again. So, yeah, and again, it'll let you do. So the AV Audio Player would only let you do local URLs, right? It won't let you specify URL in the cloud, but the Audio Cue stuff will. So if you feed it a URL for, say, some streaming website that the Cue APIs support, it'll actually take care of all the HTTP traffic and pull it down for you. So now audio units is another way of doing audio processing. This is, again, audio units under the hood is what a lot of studios use, or what a lot of professional applications use for audio processing. The parallel to audio units in the real world is studio equipment, right? Music equipment. If you've ever been into a studio, or if you've ever seen how these things are hooked up, it's several different boxes, right? Each one, like, you have an effects processor, you have a synthesizer, you have a reverb. You hook all those together. You can have several of those. Hook them into a mixer, and then the mixer takes several tracks. It'll mix them in certain ways. The mixer has EQs and levels and all that stuff. And then the audio units can have outputs as well. So there are these processing nodes that can have n inputs and n outputs. And they'll process audio in whatever way you tell them to. So, as an example, I could take an audio input unit, which I'm going to feed buffers to, and then I can pass it to a reverb unit. And that reverb unit can feed into a mixer, and that mixer can take 2 inputs. And on the other input, it takes, let's say, input from the microphone. And then you're going to add an echo unit to that and feed that into the mixer. So you have what you just built there with those audio units is microphone effects processing engine. If you ever seen like the T-Pain app, that's done through audio units. I believe they wrote their own audio unit for doing the auto-tune. Right? Everybody knows what auto-tune is because you hear it on the radio every day. That's down at the audio unit level. That's how they do that stuff. So again, very powerful, and this is what the studios use. So this is really useful if you want to do DSP. The last one I want to talk about here is OpenAL. So again, OpenGL is all about rendering 3D, right? You specify objects, and the objects have points and shapes and textures. OpenAL is very similar in that you specify point sources of audio, you specify a microphone, and based on you specify an orientation, right? So if a piece of, let's say, an audio source moves in space, what it will do is it'll re-render the audio to fit the head, right? There's the way we, as humans, the way we recognize spatial sound, the way we can tell that dog barking is from over there and that door slamming is from over there, is by taking the phasing of the sound and the time difference. It's a split second, but the time difference between that door slamming hitting both ears. And OpenAL will actually synthesize that. So if you take you have a virtual door slam and you say that the head microphone is here, if the user is wearing headphones, it's actually going to sound like it's coming from over there. So I believe there's effects processing as well. There's textures, so you can tell it that it's, it can bounce off metal, it can bounce off wood, stuff like that. And I'm by far not an expert on the OpenAL stuff, but if you're interested in that stuff, or if you're building a 3D game and you want to get really sophisticated with audio for your final project, or even just general interest, go take a look here at openal.org, and they'll tell you a little bit more about it. That was audio playback. I want to talk a little bit about audio recording now. There's 2 different ways you can do. Yes?
Can you access iPod library?
Question is, can you access iPod library? And yeah, I will get into that. There's limitations on it, but we'll get into that. So the AV audio recorder, right? So you want to input sound. There's 2 ways to do it. The first way is with AV audio recorder, and this is very much a parallel to the AV audio player. It's a COCO API, very simple API, and some delegate callbacks for understanding when recording began and stopped, and you got interruptions. It does provide metering, so you can find out. Let's say you want to listen for microphone input. You can show amplitude meters to show what when the person is speaking, when they're not. And it does sample rate conversion and format conversion as well. So you can specify to the AV audio player that you want to init with settings, and those settings are different audio formats. So here's an example of that. So you actually create an AV audio recorder with a URL. And that URL is, of course, it's not the source, because you're recording. It's the destination. And the AV audio player will append the data to that URL. I'm going to pass in nil for settings, but I could have passed in, I believe it's a dictionary. And that dictionary could have properties for sample rate and format, compression, stuff like that. And you can get an error out in case there was a problem. For recording, right, you can say, let's say just like in our example app where we were toggling the playback and pausing, we can do the same thing here where you can record and you can pause. So, and as you record, as the queue fills up, it's going to write those things to disk.